Welcome to PO2 Chapter 3.5, where we look into the world of Buzz Lightyear, because we're going to sum to infinity and beyond. This lesson, we are looking into divergent and convergent, two different type of series and sequences. So, a sequence converges. A sequence converges if it tends to or get closer and closer to a certain value. So it converges to a value. Okay, so it converges to a certain value and diverges if it does not tend to a certain value. For example, 8, 4, 2, 1, 0 0.5, 0 0.25. You could imagine it's actually the number is getting smaller and smaller. So we are converging to, this is converging to 0. Okay, so this is converging to 0. And 9, 9.5, 9.75, 9 point, if you can put a count, if you don't know the decimal version, there's 9, 9.5, 9.75, 9.875. You can see we're getting smaller and smaller. This one actually converging to 10. Next one, 5, 8, 11, 14. We're adding 3 each time. So you could see this is diverging. Okay, diverges or diverging. It does not get closer to any certain value. So hence this diverging. Okay, so this is divergent. So the first two are convergent, and the last one is a divergent. A series converges if the infinity sum of the terms add up to a certain value, and diverges if the infinity does not add to a certain value. For example, 1 plus 2 plus 3 plus 4 plus 5. You keep adding a number, keep adding number. You could see now, if you ignore the plus 1, 2, 3, 4, 5, the next few times will be 6, 7, 8, 9, 10. If you continue the sequence, not series, we ignore the plus. Okay, just think of it as a sequence. 1, 2, 3, 4, 5, like the previous first part. Okay, you can imagine the sequence can go on and on and on forever. Now, if you end up to maybe infinity, if you keep adding all these numbers, think of it. Does it add to a certain number? No, it doesn't, because you keep adding number, it becomes bigger and bigger and bigger and bigger until where? You don't know. So it diverges as it could add to an infinitely large value. Okay? This could be me, my stomach, when I'm eating desserts. It diverges. I could eat as much as I can, and it's endless. But for the next one, 1 minus 2 plus 3 minus 4 plus 5 minus 6. Does it diverge or converge? I'll let you think about this. When you add a certain number, do we get closer to any value? Yeah, so when you add the number, do we get an answer? This one, again, it's like a dessert. It's endless. Why? Because it's like me in dessert. Because 1 minus 2 is negative 1, right? 3 minus 4 is minus 1. 5 minus 6 is minus 1. If you keep on and on and on, that means you keep adding minus 1 each time. The number, the sum, will only get to a very negative number. It just goes on and more and negative, negative. So we'll say it diverges. Okay, it diverges as it is getting away from 0. Or you could say, or, okay, alternatively, or it is adding towards a large negative number, or you can say negative infinity. Infinity. The wording does not matter. We do maths. Actually, it does, and just not in this part. But you get the idea. It just doesn't add to a certain number. Minus 1 is minus 2, minus 1 again, minus 3. It just keep on going minus 1 to where? We don't know, right? But the next one, 1 plus 0 0.5 plus 0 0.25 plus 0 0.125. Now you can see numbers, the number we're adding each time is getting smaller and smaller and smaller. So the next one will be, what's half of 0.125? 0.065? 0.0675? Let me put in a calculator. 0.125 divided by 2. Yep, 0.0625. So you can see number we're adding each time is smaller and smaller. So you can try putting a calculator. Okay, add a few times. Can you see where we're getting to? Actually, if we keep adding more numbers, it will converge to 2. Okay, this is probably like my stomach when I'm eating vegetables. I could only contain so much variables. It become my I become my before I throw up. So it converges to 2. Okay, 2 vegetables, 2. Okay, so I can eat 1, 0.5, 0.25, 0.125 until to the point where you keep adding small numbers smaller each time, because as the number gets smaller and smaller, it adds to the sum less significant. That means you're adding less and less significant. Imagine you have, imagine it's a cup of water, okay, a glass of water, a glass of empty glass. You add, okay, half a glass, and then 1/8 of a glass, and then 1/16 of a glass, 1/20, 1/32 of a glass, and then until to a certain point where you start adding just droplets of water, which doesn't really add much to the total. So this converges to 2. Okay, this is what we call converges to 2. So this also what we're learning today, which is about sum to infinity, about the converging series, converging sequences. So understanding difference, okay, you can see in here 1 plus 0.5 plus 0.25 plus 0.125. Why does this infinity converge to 2? You can say because the R equals a half. If you look at the ratio, okay, not ratio, sorry, what do we call that again? The multiply. I was going to say multiply. What do we call the R thing? Common ratio. Yeah, it's a ratio. My bad. It's a ratio. Yeah, it's a ratio. Okay, so each time we are multiplied by a half, right? So we're timesing by a half each time. Now for X, but this one, we're timesing by 2 each time. So R equals 2. So what does that mean? So if, okay, so in here, before we do that, so if -1 is R between -1 to 1, okay, or we use a symbol, a much neater way, is the modulus of R is less than 1. Now learn this. You actually use this in binomial expansion as well when it comes to validity. You can use this. So R, the modulus of R is less than 1. It means it is a convergence, is a convergence. The sequence is convergent. That means we keep adding to a smaller and smaller number. So we get to the final number, final answer. But if, okay, the modulus of what R is greater than 1, okay, that means R is either less than -1 or R is greater than 1. Okay, then it is a divergent. Now, for those who are not doing maths in uni, that does not really matter in here, but in uni you probably get to do a little bit more of this. You actually hate the series, or doing further maths, you probably get how they hate the series already. But anyway, for now, it suffices, if you're just doing maths, suffices to say, just have to learn about convergent. Convergent means term by term, we're adding a smaller number. So a geometric series is convergent if, I just told you, the modulus of R less than 1. The formula. So what's the formula? Well, the formula is Sn equal a. Oh, okay. So, okay. This is geometric series formula. I want to show you the proof. Okay. So this is geometric series. Okay. This is geometric series. Okay. But that's not the formula about sum to infinity. Remember I said we have to learn 5 formulae. This is you are going to learn the 5th one. Okay. So there's a 3rd formula, 4th. I can't remember. Anyway, so what we know is, okay, as n tends to infinity, that means we think about n being a very big number. We add so many terms, then imagine, okay, imagine in this series, 1 plus 0.5 plus 0.25, this is S1, S2, S3, because the 3rd term, S4. Now, Sn, imagine, is a very, very big number, okay, as in number, very big position of term. Think of it like the 100,000 millionth term. So Sn tends to infinity, okay? So in here, yep, I do want to show you the wording. Okay, so this means, this arrow means tends to. You actually have that used this symbol before in differentiation, first principle, as h tends to infinity, or h tends to 0, right? So as n tends to infinity, okay, r to the power of n, okay, equals to r to infinity. So we'll look at this term in here. Anybody might be wondering what we're doing in here. Now, because r is less than 1 in converging series, therefore, okay, r to infinity, if you can hear next to it is my series. So r to infinity tends to 0. Now, because r is a number less than 1, now think of it as a 0.5. Now try to put 0.5 to the power of 1,000, to the power of 500, to the power of 1 million. What do you see? You should see a very, very small number, or the calculator might just give you 0. Okay, because a number less than 1, a decimal number less than 1, when you make it power bigger and bigger and bigger, then the whole number just tends to 0. So therefore, what does that mean? Therefore, okay, if we replace Sn as S infinity, that will equal to A times 1 minus R to infinity over 1 minus R. And we know R infinity tends to 0, so A times 1 minus 0 over 1 minus R. Therefore, S to infinity equals to A times 1 minus R. And that is the formula we need. Okay, so that's the fifth formula, sum to infinity and beyond. No, just kidding. So sum to infinity is A over 1 minus R. So we use this quite simply when you see the question about infinity, you know. So let's have a look. Find a sum to infinity. Let me different color. For each of the following geometric series. So A is 1 plus 2, 1 plus a half, plus a quarter, plus 1/8. So we know in here the ratio is a half. Okay, so S infinity equals to A 1 times 1, no, A over 1 minus a half. Put in a calculator, you get 2. That means this sum will add up to 2. Simple as. Next one, part B. A equals 27, R equals negative a third. As long as this number is less than 1, that should be fine. Even though it's positive, negative, it doesn't matter. Okay, so S infinity equals to 1 over 1 minus R. R is minus a third. Put in a calculator, okay, you'll be surprised, that equals to 81 over 4. That means this sum, okay, you add up to, as you add more terms to it, you'll get closer and closer to 81 over 4. Okay, question C. A is P and the ratio is P as well, because you multiply by P. You're told P is less than 1, between minus 1 and 1, so you know P is a smaller and smaller number. So we can do S to infinity of A P over 1 minus P, and that's the answer. Okay, right. So more. Example, the fourth term of geometric series is 1.08 and the seventh term is 0.23328. Now, we've done so many similar questions before where they give you a certain number of term and then another term which is a few positions after. Now, this type of question, the best thing to do is actually count the terms. So the fourth term, so 1, 2, 3, 4, 1.08, 5, 6, fifth, sixth, English, seventh, 0.23328. We know it's a geometric series. Okay, show that this series is convergent. So, well, how do we do this? Well, what we can do is we can work out the value of R. Okay, let's work out the value of R. So 1.08 times R cubed equals 0.23328. Now, alternatively, you can also use AR to the power of n minus 1, which I'm not going through that. So you can, well, I will give you a small hint. You can do the fourth term, so AR to the power of 4 minus 1, which is 1.08, and AR to the power of 7 minus 1, which is 0.23328, and then simultaneous equation, and you can find an R. But you can see that's a long way round. So what we do is we tend to do the simple things. So let's divide by 1.08 and then cube root it. And that should give you 0.6. And to show us a conversion, hopefully you remember the definition of conversion. Now this could happen in exam. Okay, so one marker you have to know. So definition, what's the definition of conversion? Conversion is you have to show the modulus of R less than 1, which is exactly the case. So because 0.6 is less than 1, therefore it is a conversion. Now you have to know this. And divergent as well, if they ask you about divergent, so you have to know. Okay, the question could be, why is there no sum to infinity? Okay, so I'll just type the question here, okay? It's nothing to do with this one. So why is there no sum to infinity for this series? Okay, for example, e.g., then you have you have to work out. So what you want to do is you want to work out value of R and show R is the modulus of R. I don't know how to put the bar. Is there a way I can put the bar? Oh, wait, you have to say, I'll write down. And you have to say, okay, to show the modulus of R is greater than 1. Okay, therefore, divergent. Therefore, no sum to infinity. Now, this has happened before, so it has been asked before, so that's why I want to make sure, infinity, I can't spell infinity. Okay, but in this case, they want to show is convergent. So convergent means the modulus of R has to be less than 1. Part B, find a sum to infinity. Well, simple. So S infinity is nothing more than just an easy, simple formula, which is A. So we have to work out A. I guess that's the annoying part. To work out A, I guess you can work backwards. So divide by R, divide by R, divide by R. So A, let's on the side track, let's work it out. So A equals to 1.08 divided by 0.6 cubed, because divide by R, divide by R, divide by R is the same as dividing by R cubed. So 1.08 divided by 0.6 cubed is 5. Oh, how convenient. 5. So let's go back in here. 5 over 1 minus R, 0.6. Put in the calculator. 5 over 0.4, which is 12.5. Yay. Done. Okay. Right. Oh, one thing actually I do want to mention is a series. So if I want to be, politically correct and mathematically correct, series means I should be adding all these terms together rather than putting a comma. But, it doesn't matter. Sometimes a little bit loose with our terms that we're not always politically correct is always fine. Right, okay, so next one, example. For a geometric series with the term A and common ratio, if you want to do that, you feel free to pause the video and have a go yourself, really. Find the positive values of R. So let's read the question. So what do we know? Find for a geometric series for the first term, A and common ratio R, S4, okay, S4. So what's S4 again? So remember Sn equals to A times 1 minus R to the power of n over 1 minus R. So that's something you should be recalling, okay? We're using this formula, not the arithmetic one, because we're told geometric, okay? So you have to recall the four formulae. Arithmetic series, arithmetic sequence, geometric series, all right? So this is a geometric series. Before we start, let me ask you again, before we do anything, what's the difference between a sequence and a series? A sequence is counting the terms. A series is when we add all the terms together. Okay, so know the difference. So S to infinity, that's sum to infinity. We know sum to infinity. So S infinity equals A over 1 minus R. So, well, without further ado, let's set up the equation. So we know S4 is 15. So that S4. So S4 is A times 1 minus R to the power of 4 over 1 minus R equals to 15. And on the other hand, we know S to infinity is 16. So A over 1 minus R equals 16. So how do you solve this equation? Well, we can make A the subject, perhaps. I think we can make A subject. Yeah, I think that sounds fair to do. So A equals to 16. Oops. 16 times 1 minus R. I'm thinking, is there a quicker way we can do this? Is there a quicker way we can do this? 1 minus R. I don't think so. So let's sub it in. Okay, so 16 times 1 minus R times 1 minus R to the power 4 over 1 minus R equals 15. So what I've done is I've just replaced A, and I realized I could cancel out the 1 minus R because that's as a bracket I can cancel out. So I'm just left with 16 times 1 minus R to the power 4 equals 15. So make R a subject. So 1 minus R to the power 4 equals 15 over 16. Bring the R to the power 4 left hand side. Take away the left hand side is 1 over 16. So R equals 4th root of 1 over 16. When you do, now you might be, okay, now read the question. Find the possible values. Okay, run off breath. Is you got plus and minus. So you get plus and minus. So whenever you do even power of roots, square root, 4th root, 6th root, 8th root, then you must have plus and minus. Okay? Part B. Given that all the terms of the series are positive, okay, given that all of them positive, so they're telling you R is positive. Okay, so R is positive at half. Find the value of a. So r is a half. So a equals to 16 times 1 minus a half. So a equals 16 times a half, which is 8. All right? Yeah? Okay. So it's just a mixture of different kind of question we're looking in here. And the last one, exam practice. Pause the video, have a go at the question. Okay. Whenever you're ready for the answer, you can press play. Here are the final answers. I feel like I've done this question before. Maybe I'm wrong, but I think I do. But anyway, but if you didn't get it right, then I'll explain why. But if you got it right, that's the end of the lesson for you. Okay, good job. So let's do part A. Okay, again, this type of question where you're given certain number of terms, I tend to count them. 192, 144. I was told it's a geometric series. That means I multiply by the same ratio. So 192 times R equals 144. R equals 144 over 192, which is 0.75. Easy peasy. Part B, find the first term. To find the first term, you can divide by R. So 192 divided by R equals 256. That's A. Part C, even simpler. Infinity. A over 1 minus R. 256 over 1 minus 0.75, which is, 1024. And part D. Yes, I'm quite certain I've done this question before. Find the sum of this. Find the sum of the first n terms of a series that exceed a thousand. So we know Sn equals a times 1 minus r to the power of n over 1 minus r. So let's sub in some numbers, and we know this has to exceed 1,000. Now, I've explained this question before. Maybe the easiest thing to do maybe is to let it to be 1,000 instead of make it greater than. So you don't have to worry about the sign when it comes to the inequality. So what I'll do is I'll do 256 times 1 minus 0.75 to the power of n over 1 minus 0.75 equals 1,000. So I would multiply the denominator to the other side, 0.25, so that's 250, divided by 256 over, that's 250 over 256. Then I will make this positive, okay? So by moving this right hand side and this to left hand side, so 1 minus 250 over 256 equals 0.75 n. Now, when n is in power, take log on both sides, or take ln if you prefer. I'll do ln. This one, I think, is just 6 over 256 over ln 0.75 to the power of n. Now, why do we take ln? Because n is in the power. Whenever the variable is in the power, ln or log helps you solve the problem. Because of the power law, it allows you to take the power down. So ln 6 over 256 equals n ln 0.75 divided over, so ln 6 over 256 divided by ln 0.75. I think you should get 13 point something if my memory serves me right. 6 over 256 divided by ln 0.75. Yep, 13.04. Yes, I'm pretty sure we've done this before. 13.047. So n has to be 14 because you can't have 13.047th term. So that means when n equals 13.047, the series goes to 1,000. But if we want to exceed 1,000, it must be the 14th term. All right, I hope that makes sense. And that should be the end of the lesson before looking at segment rotation, which is, I gave you a bit of spoiler. Bye bye.